Let's put everything we've been talking about together to discuss a topic that comes up very frequently on the test, and that is linear functions. Now, for the past bit of time here, we've been discussing functions in general, and I hope at this point you're at least comfortable with what functions are and how they work. But we're going to focus on a particular kind of function that comes up very, very frequently, and that is a linear function, or as the name suggests, a function that can be drawn as a line. There are all sorts of nonlinear functions you can draw, and we'll get to those in the more advanced chapters. But for now, I really want to focus on the ones that can be drawn as a line. Now, I'm going to start by writing an equation on the board that you may recognize. You may very well recognize this. It might ring a bell. Y equals mx plus b. And if that doesn't ring a bell, don't worry, I'll explain it a little bit. This is the generic format for a linear function. Call it like the blueprint for any linear function. If a function can be drawn as a straight line, then it will fit into this equation. And let me explain a little what I mean. So I'm going to use a specific example. Y equals 2x plus 1. Does everybody see how this equation matches the generic version up above? In this case, the m is 2 and the b is 1. As we saw with this example previously, I could list out a few points on this. 1, 3, 2, 5, 3, 7. I'm going to add one more. 0. What happens when I plug in 0 times 2 plus 1? There we go, it's 1. And then, of course, I could graph this on the xy coordinate plane. And when I do, I'm going to accelerate a little through this because we've already done this. When I graph it, I find that I get this nice straight line, right? That goes like this, right? 1, 3, 2, 5, 3, 7, and on and on and on and on. So we can think of this line not so much as a line, but rather an infinite collection of points. How does that sound, right? Because this goes on and on and on. I can find points all the way down to negative 1,000,000 and up to 1,000,000 and beyond. Okay, but the bigger picture that I want to make here is that this equation, y equals 2x plus 1, fits a format, which is this. And this format tells us very specific things about the function. When you have something in this format, y equals mx plus b, the m represents the slope of the line, and the b represents the y-intercept of the line. So let's talk about that. We calculated slope in the previous video, right? I think we took 1, 3, and 3, 7, and we did 7 minus 3 over 3 minus 1, and we found that the slope was 2. And sure enough, in the equation, the slope is 2. What about this y-intercept business? Well, the y-intercept is just the point at which the line crosses the y-axis. And the way to find the y-intercept is to plug in 0 for x. So in this case, I plug in 0 and I'm left with 1. So the b, the y-intercept, is 1. And I'm really going to take a moment here and take a dramatic moment and bold this and say, this is an equation that you must know. You must be very, very comfortable recognizing this, this generic equation, this y equals mx plus b equation. And you should be able to go back and forth from an equation to a table to a graph, or a graph to a table to an equation, or whatever they throw at you. Not only do you have to recognize this y equals mx plus b format, right? You have to be able to recognize when it's almost that format. Let me show you what I mean. Pretend instead of saying y equals 2x plus 1, they had said y minus 1 equals 2x. Well, as it's written right now, it's not in the y equals mx plus b format. But I can very easily make it so, right? I just add 1 to both sides. And the reason I know to do that is when I look at this equation, I say, well, it's not in y equals mx plus b, but I can just move it and it will be. So recognizing this equation when it comes up and recognizing when you almost have it and you can manipulate it when it comes up. Let's try some practice here. Practice makes perfect. Pause the video and try these questions out. All right, in the xy plane, line K contains the points -8, 3, -3, and 10, 42. Which of the following is the equation of line K? Well, if you're a visual person, like I am, it's helpful to doodle. Even if you're not a great artist, which I certainly am not, just sketching it out can be very, very helpful. So let's do that. I'm going to draw this xy coordinate plane, and I'm going to put these points in very, very approximately. -8, -3, I'll maybe put there, and then like 10, 42 is up there, and I'll label these two. -8, -3, and then up here I got 10, 42. And so then there's this line, straight line right there, boom. That's line K, right? Line K goes through both of those points. And my job is to figure out which of these equations represents this line. Well, how the heck am I going to figure out a full equation from just 2 points? You might notice that all of these equations follow the y equals mx plus b format. Did you notice that? I hope you did. Y equals mx plus b. Y equals mx plus b. Y equals mx plus b. Y equals mx plus b, and on and on and on. And I could have been much more mean here. I could have very easily mixed these up a little bit, but we're just getting started, so I put them in all in y equals mx plus b format. Okay, so really what we need to do is figure out what the slope is, which m is the right one, and then we'll figure out what the y-intercept is. Let's start with the slope. Now looking at this, I have 2 points. I can figure out the slope, right? And I can do that by either doing the y1 minus y2 over x1 minus x2 thing, if you're more algebraic. But if you're not, we can use rise over run. Let's do rise over run first. So if I start at a y value of -3, over on this point right here, how far do I go up to get to 42? I go from -3 all the way up to 42. That's a rise of 45. And to go from an x value of -8 horizontally, how far do I run to go from -8 to 10? Well, I run 18 in the positive direction, to the right. And again, we could have done the formulaic way, which is to say 42 minus -3, so plus 3, over 10 minus -8, or 10 plus 8, and that gives me 45 over 18, right? And I'll divide top and bottom by 9, right, which gives me 5 over 2 to simplify this down. And would you look at that? There's only one equation that does it. There's only one equation that has a slope of 5 over 2. So if this is test day, I'm done, right? Like, I have my answer option. I'm not gonna stop and smell the roses and be super sure. But let's do this next part just so that we practice doing it, because you might need to actually do it on test day. Pretend maybe there were 2 equations that had 5 halves as our m. So I know the answer is B, but we're going to go a little further here. How do I figure out what the missing B is? Well, let's write what we know so far. We know that we have y equals 5 over 2x plus b. How do I find that missing b? Well, all I got to do is take one of the points. Doesn't matter which one. I could take this one, I could take that one, and substitute it in for x and y. So in this case, 10 is my x and 42 is my y. I'm going to write this as 42 equals 5 over 2x plus b. I just got not 5 over 2, 5 over 2 times 10, because my x is 10. Excuse me, there we go. Right, the 10 is in the x spot. And then what I'm going to do is solve this. So 42 equals, what's 5 halves times 10? You can use your calculator here. 10 divided by 2 is 5, times 5 is 25. So 42 equals 25 plus b. Subtract 25 from both sides. I find that b is indeed 17. So that's the correct answer. All right, let's look at this one now. It's one thing to solve linear functions in a nice, organized, formatted way. It's another thing when you get out into the real world and have to start dealing with linear equations in real life, as we are here. So here's this equation that they give us. I equals 2.25x plus 4. The equation above gives the total price for a taxi ride in dollars, I. The price consists of a flat fee when the customer enters a cab and a charge for each mile driven. Of the following, which is the best interpretation of 2.25 in this equation? So this is a little bit of an untraditional math problem, right? Usually we're used to solving for something, but here it wants us to kind of label instead. Well, let's go back to the equation that they give us. I hope you notice this is a linear function. Y equals mx plus b. And I realize they don't use y here, they use a different variable. But it might as well say f of x equals 2.25x plus 4, or y equals 2.25x plus 4. Recognizing this in all its permutations is very important. Okay, so if this is a linear function, which it is, we know that I represents the total price of the taxi ride, right? So the total price of the taxi ride consists of a flat fee. Well, what here is flat? What does not change? This term might change, right? Depending on what x is, this is going to get bigger or smaller. But 4 is locked in. So 2.25 is not the flat fee. 4 is the flat fee. And if we're applying this to our linear function graph, what is it? What's the flat fee? That's the y-intercept. It's built in, right? No matter what, when x is 0, I is going to be 4. And 4 is a constant, it doesn't change. So 4 is the flat fee. We're looking for 2.25 though. So we know that it's not the flat fee, right? So we want to know what 2.25 is. The price consists of a flat fee when the customer enters a cab and a charge for each mile driven. Okay, so there's a charge for each mile driven. What changes in this scenario? Well, it's the number of miles, right? So if I drive 1 mile, it's going to be a certain amount. If I drive another mile, that's what x represents. So x is the number of miles that I'm driving, right? We're not dealing with the number of customers. X represents the number of miles that I'm driving. So by process of elimination, 2.25 must represent the charge for each mile that I'm driving. And if this doesn't quite click, think about this on take an example, right? If I drive 2 miles, I'm going to do 2.25 times 2 plus 4. The 4 stays the same. The charge per mile stays the same, but the miles change. So the correct answer here is A. Because this is so important, we're going to do a little extra practice on it. So pause the video and try these questions out. A line in the xy coordinate plane contains the following ordered pairs. An equation representing this relationship can be written in the form y plus 14 equals jx, where j is a constant. What is the value of j? All right, well, let's cling to the familiar here. What do we recognize in this problem, or what looks kind of like something that we recognize? I hope you recognize that this is almost in the form y equals mx plus b. I know it's not, but it kind of looks like that, or we could get it there. And how would we get it there? Well, we could subtract 14 from both and rewrite this equation as y equals jx minus 14, like that, right? Y equals mx plus b. In this case, minus b. It's a negative number. But the key idea is that j is the slope. We might as well rewrite this as y equals mx plus b, mx minus 14, and just say that we're looking for m, because that's what we are looking for. So how do we find that slope? Well, let's talk about ordered pairs. What are ordered pairs? Ordered pairs is a fancy way of saying points, right? XY points. So -4, -17 is one ordered pair. 0, -14 is another ordered pair. 8, -8 is another ordered pair, and on and on and on. Now, I encourage you, although I'm not going to do it myself, to draw these out. I'm not going to do it myself because I'm running out of space here, but it's a good habit to get into. How are we going to find the slope of this line, this m right here? Well, let's take 2 points and use those to calculate the slope. Again, feel free to draw it out if you feel so inclined. I'm going to take the points 0, negative 14, and 8, negative 8. So there's 0, negative 14, and then 8, negative 8, like that, right? 0, negative 14, and 8, negative 8. How do I find the slope from 2 points? Well, I subtract the y's, and I put it over subtracting the x's. Let's do that. Negative 14 minus negative 8, so that's plus 8. Negative 14 minus negative 8 over 0 minus 8. So on the top, I get negative 14 plus 8 gives me negative 6. And on the bottom, I get 0 minus 8. That's negative 8. And of course, when you have two negatives, they cancel out. So that gives me positive 3 over 4, or 0.75. That's the answer to this question. All right, let's take a look at this one here. In the xy plane, a line contains the points 4, 11, 7, 15, and 13p. What is the value of p? So this one I will draw just because I have a little more space. So I'm gonna draw this xy coordinate plane here. Little off, but what are you gonna do, right? A little tilted. XY coordinate plane like that. Sorry for anyone who has vertigo. And I'm going to draw the points 4, 11 right there, 7, 15, and 13p like that. Boom. Right, so that's what it looks like. And I'll even label them. 4, 11, 7, 15, and 13, comma, p like that. All right, well, my goal is to figure out what this missing point is. Now, it tells me that all these points are on the same line. So if I really wanted to, I could find the equation of the line, but that's quite a bit of work. Instead, let me do this. The slope of this line is not going to change, right? Right. The slope of this line is constant. It does not change. It's going to be the same slope forever and ever and ever. So if I find what the slope of this line is, from say 411 to 715, I can figure out what it is from here to here and use that to figure out p. Let me show you what I'm talking about. Well, let's start with this little stretch. From 411 to 715, what's the slope? Well, 15 minus 11 is 4, divided by 7 minus 4, which is 3. So the slope of this line is 4 over 3. Now that slope is always going to be the slope. I know I said it and I'm repeating myself, but it's important. That is always going to be the slope. So let me look at these 2 points right here, right? From 715 to 13p. And I'm going to do the same thing that I just did, but involving p. So the way to calculate the slope is p minus 15 for the y's, over 13 minus 7, which is 6. There we go. P minus 15 over 6. And I know that when all is said and done, these have to equal each other. P minus 15 over 6 has to equal 4 over 3 because that is the slope of the line, and the slope of the line does not change. Okay, so let's do some cross multiplication here. I'm going to cross multiply here, and I get 3 times this quantity, 3 times p minus 15, so that's going to be 3p minus 45, I'm running out of space, equals 6 times 4. And 6 times 4 is 24, last I checked. You're free to double check that on your own. So I get 3p equals 69, divide both sides by 3, and I find that p indeed equals 23.